Okay, this video tutorial looks at the mathematical strand of trigonometry, and more specifically we're going to focus our understanding on multiples of 45 and multiples of 30 when we're looking at using the unit circle. So what is the significance of multiples of 45? So basically recall that the circle with a radius of 1 unit and a center of the origin is called the unit circle. So we've been concentrating a lot on the unit circle. And we can use this unit circle to create an isosceles triangle with a base angle of 45 degrees. So how we do that is, if you look over on the diagram here, we've got a triangle here, all right, where we've got 45 degrees on either side, okay, meaning that this length and this length are actually both the same. Here they are highlighted by the letter A being they are the same length. So therefore that makes the point, if we think about our cosine theta and sine theta, the point being AA, or cos theta sine theta. All right. Now if we want to use our understanding of Pythagoras, okay, here we can say that a squared plus a squared equals 1 squared. Obviously 1 being our hypotenuse, or C, this is our A and our B values of Pythagoras. All right, now obviously 1 squared is just 1. This would just become 2a squared, okay? So these would make that 2a squared, which is how we get our half, because we divide by 2 on both sides. And then we square root our answer. Obviously the square root of 1 is 1, and the square root of 2 is just root 2. Okay. Also, it's important to remember that in previous videos we've looked at all points being positive here. Okay, all points being positive, sine being positive here, tan being positive in our third quadrant, and cos or cosine being positive in our fourth quadrant. All right, and that's sort of mimicked in our second diagram. Okay, if we look down here, we've got our 1 over root 2 as our coordinates. Okay, so here and here, obviously because they're both equally a, and a equaled 1 over root 2, which is explained in our top example. But obviously when we move quadrants, all right, we end up with a negative cos and a positive sine. All right, when we move quadrants, we end up with both negatives. When we move quadrants again, we end up with a positive cos and a negative sine. All right, here for our points. That's really important to understand. The actual number of 1 over root 2 doesn't change. It's just whether it's a positive or negative, depending on the angle, obviously in the middle. So we're looking at these angles here, and obviously what quadrant we're going to be in with our unit circle. Okay, so very similar when we're looking at the significance of multiples of 30. Okay, again, we can create what we call an equilateral triangle here, because we've got the radius of one side, the radius of another side, and because the angle is 60, obviously an equilateral triangle, all right, if one angle's 60 and those two lengths are the same, the base angles have to be the same, so therefore they're going to be 60 as well. This makes an equilateral triangle, all right. And then we go back to our isosceles triangle theorems, where we split it from the apex, it creates a right angle, and it actually cuts the base in half. Now, if the base, in fact, is 1 unit, when we cut it in half, that's where we end up getting our half from. All right, so there's our half, and that's where our cosine half comes from. Now, obviously, k can be anything, but let's try and figure it out. We don't know what it is yet, so we're looking now at our points, or our coordinates here. We know that the half is cosine, we know the k is sine, because obviously with our coordinates we've got cos and sine as our coordinates. And we also know the rule of cos squared theta plus sine squared theta is equal to 1. Now we can use this formula and substitute our cosine value in, all right, of a half, okay, which is where we get this from. And we then solve the equation and end up with k equaling root 3 over 2. We've gone through this in the previous video, so please refer to them if you're unsure. In other words, for an angle of where theta is 60, we end up with the coordinates of P being, or the point on the circumference being, a half, comma, root 3 over 2. Okay, and then you'll notice too that as we change the multiple of 30 with our angle, these two numbers, a half and root 3 over 2, don't actually change. The only thing that changes is whether they're a sine or a cosine, or whether they're a positive or a negative. And you should be able to see some patterns here, where the closer we are to the x axis, all right, it means that your sine values are going to be a half, and that could be plus or minus a half. And the closer we get to the y values, your sine is going to be plus or minus root 3 on 2. All right, and then it's the opposite for cosine. So here, cosine would equal plus or minus root 3 on 2, and up on the y value, cosine would equal plus or minus a half. All right. So let's have a look at an example question. We'll do A in red. It basically says, use the unit circle diagram to find sine theta, cosine theta, and tan theta. Now, tan theta is our sine theta divided by our cosine theta. So basically, if we can find our value for sine theta and we can find our value for cosine theta, then tan is going to be sine over cosine. All right, so if we're looking at theta 60, we could say here is theta 60, this is sine, this is cosine, so that's where we get these two answers. Now if we put into our calculator our sine divided by our tan, we end up with root 3. All right, if we're looking at 150, now 150 is going to be right here, that's on our multiple of 30s. So again, we've got our half for sine, we've got our negative negative root 3 on 2 for our 150. We divide those just using this formula here, and we end up with negative 1 over root 3. Now we're looking at 225, sine of 225. So looking at angle of 225, 225 looks like it's around here. All right. We've got our negative 1 over root 2, negative 1 over root 2. It's in the third quadrant. They're both going to be negative. And when you use, obviously, the tan function of sine theta divided by cosine theta, you'll end up with a tan 225 equaling 1. Here's another example question. It says, use a unit circle diagram to find the angle between 0 and 360, which has a cosine of a half and a sine of negative 3 over 2. Now, we know that cosine is positive. We know that sine is negative. All right, that means it's going to be in the fourth quadrant. All right, so we look in the fourth quadrant and we realize, oh, yep, there's the coordinates we're looking for just here, which means we're looking for this angle here. Looks like it's going up by 30. We know that this angle here is 270. Okay, it's 3/4 around. Add your 30, gives us an angle of 300. All right, so this would be 300 degrees. So real quick, in summary, if theta is a multiple of 90, then you're going to have coordinates of the point on the unit circle being 0 and plus or minus 1. All right, up here. If it's a multiple of 45, then the coordinates are going to be plus or minus 1 over root 2, depending on where it is. And if it's a multiple of 30, but not 90, then the coordinates are going to be plus or minus a half and plus or minus root 3 on 2. It's important also to remember that tan theta is sine theta divided by cosine theta. Okay, so these are some practice questions I'd like you to have a go at. Please feel free to pause the video. Once you think you've got the correct answer, continue the video and we'll see how you went. Okay, so in our first question, we had to use the unit circle to find the sine theta, cosine theta, and tan theta for 45 degrees. So 45 degrees is here. All right, obviously we've got cos theta and sine theta, all right, being our points here, which is how we get these two values. And then when we divide our sine theta by our cosine theta, we'd end up getting 1. If we're looking for 120 degrees, got 120 up here. All right, remember our cosine theta and sine theta. So we've got sine being root 3 on 2, cosine being negative a half, and then obviously when we divide our sine by our cosine, we end up with negative root 3. In our last question, we're looking at using the circle diagram between 0 and 360, which has a cosine of root 3 over 2 and a sine of a half. Now I know that these values are multiples of 30. Multiples of 30 rather than multiples of 45 because of the values that I've been given. I know that cosine is negative in our second quadrant, and I know that sine is positive in our second quadrant. So therefore, I've actually found them here. All right, negative root 3 on 2, positive a half. That's going to give me a value of 150 degrees. So theta is going to be 150 degrees.